Hello, I'm Simon Aumônier from ERM, and I'm delighted to present our paper on the influence of geography on the carbon footprint impact of Breezhaler dry powder inhaler at the Drug Delivery to the Lungs Conference 2021 on behalf of my co-authors Karen Metzi and Brett Fulford from Novartis and Andy Whiting, also from ERM. My disclosure is here just to make it clear that ERM does work for a wide range of pharmaceutical and medical device companies, including Novartis, and I don't hold stock in Novartis Pharma AG. So to introduce the paper, climate change is recognised by the UN as one of the defining issues of our time, and indeed, as I speak, the COP in Glasgow has just begun. Carbon footprints appraise the contribution to climate change made by emissions of greenhouse gases associated with all stages in the life cycle of a product or a service. We know that respiratory care contributes significantly to the carbon footprint of healthcare, with pressurized metered dose inhalers, PMDI, having a higher carbon footprint than dry powder inhalers or DPI. The inhaler used in Novartis's asthma combinations is available in the hydrofluoroalkane chlorofluorocarbon-free Breezhaler device, a dry powder inhaler, and that is also consistent with Novartis's commitment to reduce the environmental impact of its products. So the cradle-to-grave carbon footprint studies of the asthma Breezhaler family inhaled combinations that we have studied have been verified as being compliant with the Greenhouse Gas Protocol Product Lifecycle Accounting and Reporting Standard sector guidance for pharmaceutical and medical devices, and this is the gold standard for assessments of this type in the sector. The Breezhaler inhaled combinations that we've looked at include a once daily indocaterol acetate glycopyrronium bromide mematozone fuarate, or IND-GLY-MF, abbreviated, that I'll describe it as, via Breezhaler. This is the first asthma treatment approved in the EU that can be prescribed together with an optional digital companion. And that digital companion, together with an app, provides inhalation confirmations, medication reminders, and access to objective data to clinicians and to patients. And we've also assessed a once daily IND and MF via Breezhaler combination, approved at the same time as a part of the asthma Breezhaler family. Where it's used, the optional sensor lasts for 12 months, and hence this is paired with up to 12 individual inhalers in a 30-day pack during this time. The 30-day IND-GLY-MF product has been analysed both with and without this sensor, while the 90-day pack for IND-GLY-MF has only been analysed without the sensor. The study boundary excludes those sensor benefits that might result from the reduction of asthma exacerbations, rescue medications, and improved adherence associated with the information that I described earlier on this slide. As far as the scope of our analysis is concerned, a previous study had assessed the carbon footprint of the asthma Breezhaler family in selected geographies in France, Germany, Japan, and the UK, and this had shown a low carbon footprint consistent with the literature on DPI. In this present study, the scope of the cradle-to-grave carbon footprint analysis was extended to include Italy, Spain, and what we described as the most conservative scenario. This most conservative scenario represents the longest possible distribution distance that we could conceive of and assumes that all wastes are incinerated without energy recovery. And this would be the most impactful waste management route at end of life, and hence it's the most conservative approach. The most conservative scenario is used as a reliable proxy for the carbon footprint of the asthma Breezhaler family in countries where studies have not been carried out specifically. The life cycle stages altered by this change in geography are clearly distribution and end of life because of the disposition of waste management in the country concerned. On the right hand of this slide, I've got a graphic that shows the system boundary used for the study. Both products that we looked at are sold in a 30-day pack, and that consists of the device itself, 3 individual blister packs containing 10 capsules each, a paper tray, an information leaflet, and all of which is housed in a paper cardboard box. The Indgly MF product is also sold in a 90-day pack with, in this case, 9 blister packs to give the 90 capsules that would be required for this period. Carbon footprints, as I said before, are praised for Italy, Spain, and the most conservative scenario in the 30-day pack for both products and a 90-day pack for Indgly MF only. Typically in life cycle assessment and carbon footprint studies, we define a functional unit, which is the basis of our analysis for reporting purposes. This typically encompasses the specific function of the product, the duration over which this function is fulfilled, and the expected quality of that function, if that's applicable. In the case of our analysis here, the functional unit was defined as an inhaler device used for 30 days to treat a patient, differentiated according to the characteristics of the country, Italy, Spain, and the most conservative scenario. The functional unit is representative of the 2019 data collection period, and the functional unit allows an equitable comparison to be made. In this case, the Indgly MF 90-day device was assessed over a 30-day period, so we got a like-for-like comparison with the 30-day packs. So on to the assumptions used for distribution and end of life. As far as distribution is concerned, for the most conservative estimate, we've assumed that Breezhaler is transported from a manufacturing site to New Zealand, which is about as far around the world as you can go. And this is expected to have the highest carbon footprint for all geographies. As far as end of life is concerned, I've got a table at the bottom of the slide there that shows the disposition for Italy, Spain, and the most conservative estimate between incineration with energy recovery, incineration without energy recovery, and landfill. And again, as I mentioned before, for the most conservative estimate, all of the devices are assumed to be incinerated without energy recovery, which would be the most impactful waste management route at end of life. And so on to the results of the assessment. What we find is the carbon footprint for the asthma Breezhaler family products is consistent across geographies. We see very similar carbon footprints reported for Italy, Spain, and the most conservative estimate for the Ind MF 30-day pack, for the Indgly MF 30-day pack with and without the digital companion, and for the Indgly MF 90-day pack. There's less than a 10% difference between Italy and Spain, and the most conservative estimate in all cases. The carbon footprint for the 30-day pack with a digital companion is highest, and this is because of the contribution of the digital companion itself. And the carbon footprint for the 90-day pack is the lowest of all, and this is because the impact of the device itself is amortized over 90 days rather than 30 days. And then if we look at the distribution of the carbon footprint across life cycle stages, again, we see the asthma Breezhaler family carbon footprint breakdown across geographies is also consistent, i.e. we've got a very similar picture for Italy, Spain, and the most conservative estimate. And the main contributions to the carbon footprint in each case are made by the active pharmaceutical ingredient itself, by raw materials used in the inhaler, the energy used to manufacture the inhaler, and by packaging. So as far as our overall conclusions are concerned, the low carbon footprint of the asthma Breezhaler family did not vary significantly between the countries considered in this analysis, Italy and Spain, those evaluated previously, France, Germany, Japan, and the UK, and our most conservative estimate that I've described before. The life cycle stages contributing most to this low carbon footprint of asthma Breezhaler are API, inhaler raw materials, inhaler production energy, and packaging. Other life cycle stages and contributions, excipients, distribution, and end of life, make only a minimal contribution to the total carbon footprint, that is less than 10% of the whole. And the asthma Breezhaler family has a consistent environmental impact regardless of geography, and a lower carbon footprint than currently reported for PMDIs. Thank you very much for listening. Goodbye.